Hello, everyone. My name is Liya Wang. Today, I'm glad to present our work, Enterprise Large Language Models Evaluation Benchmark. I'm from the Atlassian company. And today's agenda, we will cover 4 parts: motivation, related work, and results. So as you know, we have many public benchmarks. However, those benchmarks in recent years get saturated, and those benchmarks doesn't cover enterprise context. For example, MMLU, they just cover that the subjects like chemistry, math, physics, and so they don't deal with complicated contexts for enterprise settings. So we want to invent this kind of enterprise benchmark to suit our AI development. And this graph also shows that in the past several years, you can see evaluation become a very popular topic and increase. The number of papers increase sharply. And in our Atlassian, we have many AI products, for example, like RoboChat and Confluence data and search data, Jira data. So we want to fully utilize this kind of the data, develop enterprise-tuned LLMs. To develop these enterprise-tuned LLMs, one important part is to do the evaluation. So we want to build an enterprise-specific benchmark in this work. And this benchmark will support model fine-tuning and help us select best base model and also provide that insights to focus on and also identify the future research directions. So when we build a benchmark, 3 important questions we must answer. First, what kind of task we should focus on? Second, where to collect those data and get the data labels. And then the third, how to evaluate this kind of question and answers. So currently, there's no silver bullet for evaluation. And to design that the evaluation tasks, we adopt Bloom's taxonomy. Bloom's taxonomy was invented by Benjamin Bloom and his colleagues in 1956. This framework organize education goals by complexity. It has 6 levels: remember, understand, apply, analyze, evaluate, and create. And this taxonomy is widely adopted by K-12 teachers and college instructors in USA. So we also organize our tasks in these 6 cognitive levels, and each level we have several tasks. And as goes down, the task more complicated. So in total, we have 14 tasks, and also we fully utilize LLM plus RAG, or for some problem is manual to collect the labeling labels, because LLM is much more it's much efficient, efficient, and also it's more cheaper than human beings. And also we collect a lot of the data. For each data set, we did a ablation study. We found that sometimes that the data size greater than 600 will be good enough to do the evaluation. However, for some manual data set, the annotation data set, we don't have such large data size. Any questions by far? Okay. So to collect the data and the labels for each task, we invented this, build up this curation pipeline. First, we collect the raw data set and then do the data cleaning. After that, we use LLM as a labeler to label the data, and then use LLM as a judge to judge the label quality, and then filter out those low level quality labels. And after that, we pass to human labelers to help us to validate. And after the validation, we will put those labeled data in our benchmark data set. So in our workflow, we have three parts. Label first, and this way we can be very, the annotation process can be fast and cheap. And then use LLM as judge to verification first. And this way will fill out the low confidence outputs labels, and then finally use the expensive human labeler to verify that the labeled data set. And then during that data collection, we always need to do data cleaning, because this is very, very important. The first step is we remove that double space, because our data has a lot from that Confluence page or Jira or like Rule Chat user input. So there's a lot of those kind of double space, those stuff. And also, and the Confluence page or users' queries could be duplicated. So, and the second step is to remove exact like duplication. And then the third step is fuzzy deduplicate. We use semantic embedding to remove those very similarly questions, and then to evaluate those document quality or question quality, and then put it in our data bank for downstream processing. So to build this data cleaning process pipeline, we use that IBM's data preparation kit. And so in our pipeline, we use that LLM plus human being to team up to do the work. So you can see that this kind of hybrid method can give us several benefits. As you can see that if we just use human labelers, they are very time consuming, and also they are very expensive to use, and also it's not scalable. However, for use LLM as labeler, they perform very fast and cheap. However, their performance varies, and also they lack human understanding. Maybe in that the LLMs, they maybe have the bias and ethic issues. And then if we team up that LLM labeler and the LLM-judge and the human beings together, we can achieve efficient and also fully use human human labelers expertise to guarantee that the data quality.